So the first thing we might want to know when we're thinking about sharing tasks is how long the job requires when people work together. For example, a company uses 2 printers to print its newspaper. The old printer would take 20 hours to print the newsletter on its own, while the new printer would take only 5 hours. How long would it take the two working together? So we have the old printer and the new printer. Alone, the old printer would take 20 hours, while the new would take 5. So the old printer prints 1/20th of the newsletter in an hour, and the new printer prints 1/5. They are working together, so they each work for the same amount of time, which means in T hours, the old printer prints T over 20, that is T/20ths of the newspaper, whereas the new printer prints T/5ths of the newsletter. The part that the old printer does, T/20ths, plus the part that the new printer does, T/5ths. Between them, they print the whole newsletter. All right. So this is technically a rational equation, though the denominators are both numbers. I can easily see that my least common denominator is 20, so I'll multiply both sides of my equation by 20. Distributing, I get t plus 20 divided by 5 is 4, so 4t equals 20. Combining like terms, 5t equals 20, divide both sides by 5, and I get t equals 4. What does that mean? Together, they print the newsletter in 4 hours. So, that's how this process works out when the unknown thing is the time that they spend working together. Sometimes it's one person's time that is unknown. For example, suppose Harry and Hermione are searching the Hogwarts library. Alone, Hermione could search the library in 20 hours. Together, they finish their search in 16. How long would Harry take working alone? Well, we still have information about Harry and Hermione, and alone, Hermione takes 20 hours, and Harry takes some unknown number of hours. Call it t. That means that every hour, Hermione searches 1/20th of the library, and Harry searches 1/10th of the library, 1 over t. When they're working together, they only take 16 hours, during which time Harry finishes 16/10ths of the search, and Hermione finishes 16/20ths, which is 4/5ths of the search. So the part that Harry searches, 16 over t, plus the part that Hermione searches, 4/5ths, is the whole library. Now we actually see a variable turning up in the denominator. This is really a rational equation. And it's easy to see that my least common denominator is going to be 5t. So I'll multiply both sides by 5t. Multiplying, I'll have 80t over t plus 20t over 5 equals 5t. The t cancels out here, a 5 cancels out here, and I get 80 is plus 4t is 5t. Subtracting 4t on both sides, I get 80 equals t. T was Harry's time alone. So, alone, Harry would take 80 hours to search the library. Now, the last sort of problem like this we could get is one where we don't really know either person's time, but we know a relationship between them. Suppose Batman and Robin are cleaning the Batcave because it's Alfred's day off. Alone, Robin would take 6 hours longer than Batman would. Together, they take 4 hours. How long would it take each one alone? So again, Batman and Robin alone. Well, Batman takes some amount of time, and Robin takes 6 hours more. So every hour, Batman cleans 1 teeth of the Batcave, and Robin cleans 1 T plus 6th. How long do they both work when they work together? When they work together, they both work 4 hours, which means Batman cleans 4 teeths of the cave, and Robin cleans 4 T plus 6ths. Batman cleans 4 teeths, Robin cleans 4 T plus 6ths, and together they clean the whole cave. Again, this is a rational equation, and it's easy to see that my least common denominator will be T times T plus 6. So I'll multiply both sides by that. On the left-hand side, I distribute. I get T plus 6 times 4 over T plus T plus 6 times 4 over T plus 6. On the right-hand side, I'm just multiplying by 1, T plus 6. Let's see. Here my T's cancel. Here my T plus 6's cancel. I'm left with 4 times T plus 6 plus 4 times T equals T times T plus 6. Multiplying these out, 4T plus 24 plus 4T equals T squared plus 6T. Let's see, this is a polynomial equation. In order to solve it, I need to get one side to be 0. Let's see, combining like terms over here first. 8T plus 24 equals T squared plus 6T. Now subtract 8T from both sides. Subtract 24 from both sides. I get 0 equals T squared minus 2T minus 24. I'll need to factor this. T squared negative 24. I need two numbers whose product is negative 24 and whose sum is negative 2. I think that negative 6 and positive 4 will do that for me. Here I'll have a T and a negative 6, a T and a positive 4. So that's T minus 6 times T plus 4 equals 0. T equals 6 or T equals negative 4. Thinking back to the original problem, T is the time that it takes Batman to clean the Batcave. I don't think that even Batman can clean in a negative amount of time. This isn't Silver Age Superman we're talking about after all. So we're left with T equals 6 for Batman's time. 6 plus 6 is 12 for Robin's time. So Batman would take 6 hours. Robin would take 12. Notice the one odd move we had to make here we had to decide that the negative number didn't make any sense and throw it away. All right, I'm going to give you one of these to try. I'm not going to tell you which type it is, but you should be able to decide based on just what it is you're trying to find out. Two pipes together are used to drain an oil tanker. The larger pipe alone can drain the tanker in 8 hours. When both pipes are used, the time drops to 6 hours. How long would it take the smaller pipe alone to drain the tanker? Pause the video and try this now. All right, we have the big pipe and the small pipe. Alone, the big pipe takes 8 hours, and the small pipe takes some unknown amount of time, t, which means that in 1 hour, the big pipe can finish 1/8 of the job, while the small pipe finishes 1/10 of the job. For how long do they work together? For 6 hours. And so, in 6 hours, the big pipe drains 6/8 or 3/4 of the tanker, and the small pipe drains 6/10 of the tanker. So working together, the big pipe drains 3/4 of the tanker, and the small pipe drains 6/10 of the tanker, and between them they drain the whole tanker. Here it's easy to see that my least common denominator is 4t. Distributing on the left-hand side, I'll get 12t over 4 plus 24t over t equals 4t. Simplifying, here the t's cancel. Here a common factor of 4 cancels, and I get 3t plus 24 equals 4t. Subtracting 3t on both sides, I get 24 equals t. The smaller pipe alone would take 24 hours.